A DDoS attack to bring down a web server. Let's see what the HTTP2 rapid reset attack does to achieve this. Thank you for joining. My name is Lieuwe Jan Koning, and here from the Security Operations Center floor at On2IT, we bring you Threat Talks, a deep dive. And today's subject is the HTTP2 rapid reset attack. Let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
Let me briefly welcome our guests, Rob Maas, who is a field CTO of On2IT, and Luca Cipriano, who is a Threat Intel Specialist. Gentlemen, let's see. HTTP2, first of all, that's a common version of HTTP2. I mean, it was invented to have consecutive sessions within the protocol. So to make websites load faster, we can load several images consecutive in the same session. But now we have trouble. How does this thing work?
So, well, this one is a nice one. So basically, compared to the other DDoS techniques, such as the amplification and reflection amplification or normal DDoS techniques, this one goes at a layer 7. It's on the application, and it's especially on the HTTP2, the version of the HTTP. Everybody knows what is HTTP. Normally, we use it to visit websites. This should be an improvement of the of this protocol, and basically, as you mentioned, it allows to open consecutive concurrent streams on the same TCP connection. So what happens? Like normally, I visit a website that has HTTP2, and I establish one TCP connection, and in the same TCP connection, a lot of streams are open. The amount of stream is based on what it needs to be loaded on the website. The streams can be used, for example, to load JavaScript, HTTP videos, audios, or all sort of things that compose the website. So normally, for this protocol, the client is allowed to reset these streams. Like, for example, if he wants to close the page, not loading, stop loading, etc. So it can send a stream reset to the server, and the server will close the stream. So attackers are basically abusing this function. How are they doing it? Basically, they open a stream, and immediately after opening the stream, they send the reset request, and they do this continuously for thousands of times. So what happens is that basically they can open and close immediately thousands of streams. Normally the server, for example, in the settings would have a maximum number of concurrent streams that you can have open. But since this
concurrent, it's consecutive, right?
But normally the streams work concurrently, so they're like a lot of streams together. So you have a maximum number, but exactly being this one consecutive and not concurrent, you never hit that threshold, because basically the stream is closed immediately as soon as you open it. So what happened? What this
and the protocol allows this to happen. I mean, it's the whole point of this is that you open and close
that's
streams as you need.
Yeah. Yes. Exactly. So that's how it should work. It's just used in a malicious way. Basically, it's a normal function. So what happens when? What are the consequences? The consequences is that every time you open a stream, anyway, that the server needs to start all the works to just according to what it needs to do, like load the script or whatever, and being reset immediately. All these requests together, they create a backlog of work on the server, and this leads to resource exhaustion. Because the
resource of the web server application.
The resource of the web server
necessarily, but the server itself, so the application.
Yeah.
And in that sense, it's a bit different from typical more TCP layer attacks that also use similar attacks, but those are on the OS level, and this is
it's like
animal.
If you think about, for example, the TCP scene float, that's the idea behind it can be similar, but it's different because the TCP is a lot of connection that are not the three-way handshake is not completed, and so basically, as you just mentioned, and in this case, it's only one single TCP connection that is established.
Rob, is this the protocol? Is this the implementation of the server? I mean, what's wrong here?
Yeah, the basis is in the protocol. The protocol basically allows for multiple streams to speed things up. And basically what, let's say, forget to implement is basically how do we counter against these kinds of misabuse of the protocol.
Yeah, because the amount of concurrent sessions is already specified to be limited, right?
So that's basically where we come to the mitigation. Some applications like AMS-IX have a default that said, okay, 128 sessions, that's enough. By default, you can change it, but so they kind of mitigated already around this problem.
We're then talking not about concurrent sessions, but about resets. The total sessions,
the total streams you can have as a user within one connection.
Mm-hmm.
So that's then 128 by default, and you can change it. But that's kind of a mitigation because then you can still do the rapid reset, but after 128 times, you basically need to wait till they are gone before you can start again.
And it's not to spec then, because as a client, I could expect to open 400 or so.
Exactly. So you can of course change it within in this case the parameters of AMS-IX in the application. AMS-IX as the application. So the problem itself is really within the protocol because there is basically not written down how we should cope with this. There are some proposals now that says, okay, within HTTP3, so basically the successor that will follow, has an option that's called the maximum TCP streams, limit streams, sorry, to implement that, basically backport it into the HTTP2 protocol to basically write down, hey, this is what you should do. So basically what AMS-IX already did. And then once this is in the protocol definition, then basically every implementation should follow the protocol to be compliant with the standard.
Yeah, so and that's quite a big thing that you rewrite the protocol. I mean, there's many implementations of this.
Yeah, so that's not something
every vendor needs to basically do the 2.1 version or whatever.
For now, you can basically to mitigate it. Now you can look at the application like AMS-IX if there is such a feature that supports to limit the number of streams. Another option is basically monitor all the traffic that comes in and also try to monitor all the streams. And then if you see that certain IPs are abusing basically this functionality, then basically block them for a certain amount of time, for example. And there are also services on the internet that can do that for you. For example, Cloudflare has IP jail, which basically does this. It monitors the traffic, and if they see, hey, this is probably being a user that misuses basically this functionality, they put the IP in jail for a certain amount of time. But it's not.
But it is we're talking about HTTP2. Usually, it's probably in an SSL tunnel, so it is encrypted, right?
Yeah, you need.
So you need to be able to look into that. So SSL decryption is a must, then, if you want.
Yeah, that's for a lot of threads that we discussed, but especially for this one, we have the TCP session that's encrypted. The application, of course, can see it. So like AMS-IX, because that's the endpoint that needs to decrypt it. But if you just put a system in the middle and you don't do decryption, then you can't see it. You can see it.
Yeah, from the attacker's perspective. Everything that if you don't look into SSL at all, that's great for an attacker.
Of course,
right?
it's better. Yeah.
So you should basically always do that. Okay, thank you very much, Rob. Thank you, Luca. There is more material available on our website. There's a white paper, some data sheets that you can use. You're free to use it in your own presentations, for example, and we welcome you to use it. Did you like this explanation of today? Then please follow us, like us, and also respond in the comments what you found of it. We are really eager to hear from you. And if you want to get in touch with us via email, that's also possible. Email to team@threat-talks.com. And we hope to see you next time. Thank you very much.
Thank you for listening to Threat Talks, a podcast by ON2IT Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.